Cathode-Ray Oscilloscope. The questions are related to MCQs, that is multiple choice questions, and these questions are taken from A levels. The subject code is shown here 9702, and all questions are based on the use of CRO to find out either the frequency or the wavelength or the time period or voltage. Here I will clarify once again. In CRO, we have the screen which has a grid, and the x-axis is used for time measurement and frequency measurement. Time-based setting along x-axis, we count squares along x-axis. Time-based setting is usually given in the question, or we have to decide which should be the appropriate time-based setting for particular time period or frequency. And Y gain setting or vertical axis is for voltage measurement. So this is the first question, 9702, variant 11, October, November 2013, and it is the question number 4 of that year. So here a signal that repeats periodically is displayed on the screen of a CRO, that is cathode ray oscilloscope. The screen has 1 centimeter square and the time base is set at 2 millisecond per centimeter. It means each square shows 2 millisecond horizontally. Horizontal axis is for time. What is the frequency of this periodic signal? So in order to find out the frequency, we have to see the appearance and how the trace makes up one complete wave. So in order for the complete wave, we have to find out the similar position like this. So when the next similar trace appears here, so we have to count. This is one complete wave then. So what is the time of this one wave? We have to count the square between these two. 1, 2, 3, 4, 5 squares. Either this or we can use another one like from here to not this one. After the complete all the variations are shown, and then this same variation is repeated. So this one. So here again from the lower peak, 1, 2, 3, 4, 5. So same number of blocks are occupied either this way, or what can be the third option, starting from here. That is this one. So from here to we can go to this. So again the number of blocks which are occupied, 1, 2, 3, 4, 5. And horizontally, what is the time base setting? 2 millisecond per centimeter. Each block horizontally represents 2 milliseconds. So 5 blocks. So 5 multiplied by the setting. Setting is 2 millisecond. So what is the total time for these number of blocks? 5 to the 10 milliseconds. It means time period is 10 milliseconds. All the traces. First one, the one which is marked in red, or the bottom peak, or this small one. The number of blocks are 5. So time is 10 millisecond. 10 millisecond. and frequency is equal to 1 upon T. For the frequency to be in hertz, time has to be in seconds. So 10 millisecond means 1 upon 10 into 10 raised to the power minus 3. So what will be the answer? 10 raised to the power 3 divided by 10. Answer is 100 hertz. So the frequency of this trace is 100. It means answer is B. Now the next question. It is from again A levels, paper 1, May June 2007, and question number 4 of that year. An oscilloscope display consists of two separate traces, a waveform and a long horizontal line. There are two traces shown. It means we can provide two inputs to CRO. One is long horizontal line, and this may be taken as 0 level. The grid on the screen is calibrated in centimeter squares. The time-based setting is 2.5 millisecond per centimeter, and the Y sensitivity is 5 millivolt per centimeter. It means vertically each square represents 5 millivolt, and horizontally the time for each square is 2.5 milliseconds. What are the period and the peak positive voltage of the waveform in the diagram? We have 4 options here. So which one is the appropriate answer for this question? So this horizontal line is considered as 0. So what will be the right answer here? When we check the frequency or the time period, time will be, what is the time of one wave? We may consider from this to this. So how many blocks are occupied? 4 blocks are occupied. 1, 2, 3, 4. So one block, 2.5 millisecond per centimeter. And how many are 4 block or 4 centimeter? Each is 1 centimeter horizontally. This is 1 centimeter and this is also 1 centimeter vertically as well as horizontally. So centimeter cancelled. So 5 fours are 2.5 into 4 is 10 millisecond. So the time period is 10 millisecond. And what is the voltage? We will have to see the vertical axis, and this is 5 millivolt per centimeter. Means we have to, this is 0 line. The horizontal line may be taken as 0 level. Means we have to take the peak from this to this. So there are how many blocks? 1, 2, 3 blocks vertically and this one. So this one is not complete. So it could be more than it's slightly above the middle position of the block. So what will be the voltage represented by this wave? We have to see the options, which options are most appropriate. So 5 through the each block is 5 millivolt. So 5 millivolt per centimeter And first we are checking these three. So what will be the voltage of 3 centimeter? 15 millivolt. This and this cancelled. Now, what about this? It means this is more than 15. It's not completely 20, and we don't have to start from the this position. This is not considered because this is zero line. So positive peak is above this zero line. So let us see what options are available here. Our answer is time was 10 milliseconds. So these two may be the right answers. Either this one or this one. 25 is not possible according to that trace. So 17 will be the right answer. We may have a look at the diagram once again from here. So 25, if we consider this 1, 2, 3, 4, and 5. But the fifth one is not complete. Okay, bottom it's slightly below this line, but this is not zero line. Okay, so positive peak. It is asked what is the period and the positive peak voltage. So this is negative peak. The lower one below this horizontal line is negative peak. So we have to find out the voltage of positive peak. So positive peak is 17. So answer is C. Now question number 3, and this is 9702, paper 1, October November 2002. So here a bit complicated diagram is shown because the boundary is not clear. And how many waves are shown here? The diagram shows a square wave trace on the screen of a cathode-ray oscilloscope. A grid of 1 centimeter square covers the screen. Okay, so each square is 1 centimeter in length and in width. The time-based setting is 10 millisecond per centimeter. Each horizontal axis is having time setting of 10 milliseconds. What is the approximate frequency of the square wave? So how do we count square wave in this? So in order for the wave to be counted, let us see where the boundaries are clear. If we start from here, because this is the starting one, we can ignore this one. If we start from this one, this will be 1, this will be 2, this will be 3, 4, and 5 blocks. And see the pattern, one wave ends starts this way and ends here. Then second wave starts this way and ends here. Third wave starts this way and ends here. So how many waves are there? Here 1, 2, 3, 4, 5, 6, and 7 waves. 7 waves in 5 blocks. So what is the time of each block? 10 millisecond. So time of 5 blocks. What is the total time of 7 waves? You can say. Time of 7 waves is equal to number of blocks. The formula are mentioned given in the first video related to CRO. How to calculate this? Number of blocks multiply by the setting. So in blocks 5 and setting 10 millisecond per centimeter. So there are 5 centimeters and 10 millisecond per centimeter. So centimeter cancelled. So 5 tens are 50 millisecond is the time of 7 waves. So what is the time of one wave? Time period is time of one wave. So time period will be total time 50 millisecond divided by number of waves, 7 waves. What will be answer? 50 divided by 7. That is time of one wave is 7.1 millisecond. So we have to find out the frequency of the wave. So frequency is 1 upon T. 1 upon 7.1, and time has to be in second for the frequency to be in hertz. So 10 raised to the power minus 3. So when I solve this, what will be the answer? It will be 140.8 hertz. And this is approximate frequency. So let us check. Answer 70 hertz. No. 140. Yes. Our answer was 140.8. So we can take this. Because this is 141, when we round it off up to two significant figures. So this will be 140. Now the next question, it is from May, June 2012, 9702. Again, A levels, variant 1, 2. Second variant. It is question number 30 of that paper. This needs the use of formula. A standing sound wave is set up between a loudspeaker and a wall. A microphone is connected to a cathode-ray oscilloscope, that is CRO, and is moved along a line directly between the loudspeaker and the wall. The amplitude of the trace on the CRO rises to maximum position at maximum at a position X and falls to a minimum, then rises once again to a maximum at position Y. The distance between X and Y is 33. So what is to be done here? Distance between, it falls to minimum, and then we have to see the question carefully again, is moved along a line directly between the loudspeaker and the wall, and the amplitude of the trace rises to maximum position at X, then falls to minimum, and then rises to maximum once again. to a maximum position. That next maximum position is considered as y. So the distance between x and y is 33 centimeter. So that centimeter has to be converted into meters. So what will be the which diagram represents CRO trace on of the sound wave received at x? So we have to check the time and we have to check the setting. Which one will match the wavelength and the frequency? So what is the frequency and what is the time period? For the frequency to be in hertz, time has to be in seconds, and the wavelength has to be in meters. So I have to draw the diagram. I have to give the sketch here. What kind of appearance will be there? This is a microphone, a speaker placed, and here this is the uh, detect wall, and stationary waves are set up between this. Here we are not going to discuss how the waves are set up. Stationary wave, the appearance will be what? This kind of appearance will be there. The maximum amplitude is obtained at x when the microphone is placed here. Suppose this is mic. The maximum amplitude is obtained. We call it x. And then when the microphone is moved from here and placed to the, it is moved to different position, that is to this answer will be the amplitude is minimum here because there is no sound. Maximum sound, no sound, and again maximum sound. So this is y. So the distance between x and y is given as 33 centimeter. This is node, antinode, and this is also antinode. Two successive antinodes, they make up half lambda, lambda by 2. So lambda by 2 is 33 centimeter. Means what is lambda? 66 centimeter. 66 centimeter means 0.66 meter. So wavelength is 0.66 meter. How do we know the frequency of this? Because to check which time base setting is appropriate, we need to know the frequency, and then we will find out the time period from this and then the setting. So F is equal to V over lambda. 330 divided by 0.66. So the answer is 500 hertz. So when we take the reciprocal, time period is equal to 1 upon F, 1 upon 500. So when we solve this 1 upon 500, we get 2 into 10 raised to the power minus 3 means 2 millisecond. So time period of the wave is 2 millisecond. Because time-based settings, all the settings are given in millisecond per centimeter. So that is why I have converted this into millisecond. So we have to remember this value of time period, 2 millisecond. So let us see. So what is the time of this wave with this setting 0.5 and we consider 1.5? How many blocks? 1, 2, 3, 4, 5, 6, 7, 8. So what is the total time? In setting is 0.5. So 0.5 times 8 means 4 milliseconds. So this is not the right answer of that, because according to this figure, the time period of this wave is 4 millisecond. But the time which we have calculated is 2 millisecond. Now let us check this one. B, 0.5 millisecond per centimeter. So 1, 2, 3, and 4. This is time of one wave. So 4 into 0.5 number of boxes into the setting. So that gives us 2 millisecond. So this looks the right answer because 2 millisecond was the time period which we calculated. Let us check the others as well. Here the time period is how many blocks are there? 6 blocks. 1, 2, 3, 4, 5, 6 means this is 3 milliseconds. So this is also not the right answer. And what about this one? 0.5, this is 1 millisecond. And time period actually is 2 milliseconds. So B is the right answer. So that's all for today. I'll make more videos on the questions related to CRO, maybe the structured ones. Till then,